Well, hello. Right now, I think that I am probably, I would say driving to the airport to get on a plane at like noon today to go to Disney World in Florida. That still seems so far off to me because I am recording this, of course, in advance. I'm sure you guys are all desperately missing me. That's what I like to think, at least. But luckily, I'm here for all of your hypothesis testing needs. Today, we're going to do an introduction to hypothesis testing. I'm going to be doing this pretty fast, so you need to be responsible and pause the video any time that you need to, and I will actually ask you to pause it a couple times so you can try a few things. The homework today is going to feel a little different than the math homework usually is. There's not going to be a lot of calculations. This is a lot of just intro kind of stuff about hypothesis testing. You're not going to really understand what you're doing with this stuff yet with the null and alternative hypotheses, but that will be very clear in 7.2, 7.3, and 7.4. 7.1 is just an introduction. 7.2 will be for samples with large means or that are normally distributed. 7.3 and 7.4 will be sample means and proportions, which is where you're going to be learning the math for your project. So this is just an introduction. Okay, so a hypothesis test is a process that uses sample statistics to test a claim about a population parameter. So basically, somebody makes a claim about a population, and then you collect statistics to test it, whether it's true or not. There are always two hypotheses to consider when you're studying a statistical hypothesis. There's something called the null hypothesis, and its complement, remember complement in mathematics means opposite, and the opposite to that is the alternative hypothesis. Either of these may be the claim. So if somebody's claiming something, it could either be the null hypothesis or the alternative hypothesis. It is not always one or the other, which you'll be able to determine which one it is at the end of this lesson. All right, H sub O represents the null hypothesis. And yes, I know that looks like hilarious. And H sub A represents the alternative hypothesis. I'm going to call them H sub O and H sub A, not hoes and ha's, but you might remember them better as ho and ha, but again, H sub O, H sub A. The null hypothesis is the statement that contains an equal sign. It could be looking like a straight up equal sign, or it could be a less than or equal to, or a greater than or equal to, but either way, we've got that equals to part of it. An alternative hypothesis is the statement that doesn't contain an equal sign. That is literally not equals to, which is an equals to with a line through it, or less than or a greater than. So if it has an equals to, it's a null hypothesis. If it doesn't have an equals to, it's an alternative hypothesis. If I'm going too fast for you, pause so you can write. Okay, so this is one of those charts where we're going to list like words that are identifying words that in a problem that you'll be able to understand which is which. So the first set, our H sub O is a mean is greater than or equal to a number for the H sub O. And the opposite of that, so if we have greater than or equal to, the opposite of that is less than. Because if something's not greater than or equal to, it must be less than. H sub O, it would say the mean is greater than or equal to. It might say the word at least. Or it might say not less than in the problem. And that matches this symbol right here, greater than or equal to, at least, or not less than. Over here on the other side, on the alternative hypothesis side, we have less than, below, or fewer than. Next up, we have the opposite of that. We've got mu. Remember, this is not an M, this is a U with the tail off the front. The null hypothesis could be less than or equal to, and the opposite of that is greater than. And the keywords for that, if you see them in a problem, are less than or equal to, at most, and not greater than. The keywords for the alternative hypothesis are greater than, above, and more than. These are words to watch out for in a story problem so you know which one it's going to be, because there's 3 choices, 1, 2, 3. The final one that you could be testing is mu is equal to a number, or mu is not equal to a number. Just like I said, one possibility is equal to a number. One is it might just say the mean is just a number, like it'll just say it is it, or it might say the word exactly. Over here, we have not equal to, different than, or specifically not a number. This doesn't cover every single possibility, but I mean like 99% of them. Maybe I'm like 95% confident. It's a little confidence interval joke there for you guys. Whew. Try not to laugh too hard or you might startle the sub. Okay. I'm sure so far you're thinking, okay, I've written everything down so far and I still have no idea really what a null or an alternative hypothesis is and how they work. So we're going to start doing some examples now to talk about it. So let's say that this is somebody's claim. The university claims that, or they publicize that the proportion of its students who graduate in 4 years is 82%. Okay, so for every problem like this, when you're doing a null and alternative hypothesis, you're going to write down H sub O and H sub A, what's the null, what's the alternative. So it says they publicize that the proportion, so I'm going to write P instead of mu, which by the way will be featured in lesson 7.4, proportions. So if your hypothesis test project has a proportion in it, like 45%, 70% or something like that, you're going to go to 7.4 when you do the math. The proportion of its students who graduate is 82%. Now is means equals. And I know that if it has an equal sign in it, it must be the null, so that's equals right here, 82%. This is their claim. And this one must be not equals to then. And it's not like you write something